we need to have algorithm or the controlling system, so-called super twisting. Here are some important parameters I wanted to tell you right now here. So the point in here, as you can see, is my control system is so-called super twisting algorithm, as you can see from here, which is my controller. So I selected the super twisting algorithm for my plant dynamics. I will show you later on where is my plant and where I adopt this controller mechanism in order to need the required output. So the controller is so-called super twisting algorithm. But before that, I selected the terminal sliding mode as controller, so-called TSMSC. So once I select this thing, I directly put my eye into the demerit of this controller. When I look at the demerit part or the disadvantage part of this terminal sliding mode control, there is a singularity problem. So this is a very popular and a very known problem in control system, the control design of a many dynamical system. So a singularity problem means that the entire system matrix determinant is zero. So in order to reject that zero system from our modeling system, we need to reject such kind of zeros. So for that case, this sliding mode control, terminal sliding mode control, will never omit that singularity problem, will never reduce that singularity problem. The singularity problem in this controller case is higher. So I have to shift the point of a control system. So then after, in order to solve this demerit part, I come to here and I select so-called non-singular terminal sliding mode control. That is in order to reduce the problem of singularity. So once I select the singularity problem rejection mechanism, I selected here non-singular terminal sliding mode controller, and then after I look for the two things. The first thing is what the advantage of this non-singular terminal sliding mode control. When once I adopt that sliding mode controller system for my plant dynamics, where is the output? When I look the output, the merit part. So the demerit part and the demerit part. Before I go to the demerit part, the merit part is our system is a very fast response, which have a capability to just to give us the robustness, and again we have a finite time convergency. So our convergency, the final output controller convergency is finite time, which is not infinite time, which is so-called the advantage or the merit of this non-singular terminal SMS. Look at here, which is robust, again, which is a finite time convergence. So these two things are the main advantage of the non-singular terminal SMS. So here the demerit is again chattering effect. Here is the singularity effect. When you come to here, the demerit of this the non-singular terminal sliding mode control is a chattering problem, which is not reduced in the well manner when we use such kind of controller for our plant dynamics. So in order to reject from my system is an unmanned aerial vehicle. When I use that system in my dynamics, so in the demerit part, the chattering effect is the main effect or the main problem when I use this non-singular terminal SMS for my plant. So I have to shift the point of my looking to another dynamics in order to reduce that chattering effect. For that matter, I came and I shift my controller to super twisting algorithm. As you can see from here, in order to solve this chattering effect from here, I directly select super twisting control of terminal sliding mode controller, so-called super twisting control of TSMC, which is for my plant UAV. So in order to solve the demerit part, I used this super twisting algorithm or a super twisting control of terminal sliding mode controller. So the lesson in here I wanted to share to all of my family, I wanted to share is just in order to get a chatteringless output, we need to select a good performance control algorithm for our plant dynamics. So that is the very important point I want to share to all of you. So which is so-called a controller system. So the controller selection scheme for my hexacopter UAV, which is actually done in May in 2009, which is 3 years before. So the main concept is just in order to reduce such kind of a chattering effect, so we need to select the super twisting algorithm. So this is the first, I think, from the theoretical. I think I have covered the so-called sliding mode controller, the mathematical part, the mathematical analysis. But here is from the research point of view, I covered about the selection criteria of the control algorithm. So next time we'll see about the internal kinematics of this super twisting control algorithm of so many adaptation. Super twisting control algorithm with proportional, derivative, and integral controller. Super twisting algorithm or super twisting control of terminal SMSE. Super twisting algorithm with another controller systems with a biomanner. So this is it. Don't forget to be a family. Don't forget like, share, and subscribe to this particular channel. So thank you for this